Welcome to Section 3. In the previous section, we saw how to acquire data from various sources. In this section, we will be preparing data for analysis. We will first clean the data and then blend it to create a data frame. So, let's get started. In this video, we will be looking at cleaning data sets. For that, we will look at normalizing strings, changing case of strings when required. We will also look at handling outliers in data sets, as well as the date formatting. Whenever we are given a data set to analyze, chances are that it will be a dirty data set. So, what do we mean by a dirty or messy data set? The data we are presented with will most likely have inaccuracies within the data, incomplete or missing data, duplicate data, incorrect data associated with the field. This video will allow you to start cleaning that data set, ready for use. The first task to perform with the string is to potentially remove any padding. This is because the string space 1, 2, 3, 4 does not equal simply 1, 2, 3, 4 without space. In the example shown, the string hello world has a space at the beginning, at the end of the word. From the string our library, I can use str_trim to remove the white spaces. Just like this, and it returns string print. Another case is when displaying a value in a neat columnar format, padding can be used to assist. The function str_pad takes our value 1, 2, 3, 4, 5, sets the string to 6 characters wide, and then selects the left side of the string to add the padding character 0. The returned value is now 0, 1, 2, 3, 4, 5, indicating that padding character was added in the left side of the statement. Changing the case of a string may also help when performing a comparison. This is because some string values may have mixed case or may be all uppercase. If we try to compare hello world in uppercase with hello world in lowercase, the comparison will fail. We can use the functions to upper or to lower to change the case of a string for comparison, just as this. Here we have hello world in uppercase. Similar operation, but we have hello world in lowercase. Another case is dealing with outliers. Outliers are simply values in a series, which are either too large or too small. The outliers can have a significant impact on any statistical analysis that is carried out. In the example shown, I have a vector of values 1 to 10, plus 20 and 30. The numbers 20 and 30 are outliers. Here is our array. I can use a box plot to identify and remove the outliers from the sequence. It can be done using an expression as this. Here, we filter all the outliers, and now we are having an array that contains only values that are not outliers. The next issue to come on to is data values and how we can display dates, change their display format, and convert them from string to allow manipulation. In this example, we take a string value 2016 12/25, which is obviously Christmas Day 2016, and work out how many days left until that date. The first task is to convert the string to a date. To do that, we use the function a.date. Using the sys.date function, I have a record of what this date is. Using simple math, I can work out how many days left until Christmas by saying my variable Christmas minus my variable today. When I wrote this, there were 99 days left before Christmas. There are certain variables I can use within the date function to specify the format I would like to store, use, or display dates, not forgetting that dates vary from one country to another. For example, Christmas Day could be written as 25/12/2016 or 12/25/2016 or even 2016/12/25. This could cause a problem for users who may be used to a specific date format. I can therefore use variables shown to change how a date is displayed or stored. As seen earlier, I can have a date 2016/25/12, which represents Christmas Day 2016, using the format function and the variables from the previous slide. I could specify how I would like to display that date. Here is a sample. %D states that I would like to store the day of the month value first. The separator character is the \. Next, %M states I would like to use the numeric value of the month rather than %B for the short name or %B as the full name. Finally, I want to use %Y, which is the short 2-character value for the year, rather than %Y version, which displays all 4 characters. The returned value is therefore 25/12/16. In this video, we have looked at some of the most common techniques available for cleaning data. There are many more available, and we will be looking at others within this course.